Hello everyone. This question has been taken from Olympiad Pathfinder, Chapter 12, Multiple Choice Question number 10. The question says, electric field lines of a portion of an electric field that is symmetrical with respect to rotation about y-axis are shown in the figure. So this is y-axis and this is x-axis. About y-axis in rotation, the field is symmetrical. A charged particle stays in equilibrium at point 0, 10. At this point, if modulus of charge of the particle is changed gradually till it shifts to another equilibrium position 0, 0, estimate the fractional change in the charge modulus. Let us solve this question. The question says particle having a charge, let us say that charge be small q, is kept here initially and it was in equilibrium. Then later we started extracting or adding the charge in it, we don't know. And the next equilibrium position is at 0, 0, means at this point. This one is y-axis, this one is x-axis. In question, nothing has been given about the gravitational field. So we should assume that the gravitational field is towards the negative of the y-axis. So at this point, the charge is having some mass, the particle is having the mass and the charge on it. So mg will be acting downwards and electrical force will be acting upwards. Since it is in equilibrium, so sum of these two forces should be 0 at 0 and 10 position. Same way, when the charge has changed, but the mass is not changing, nothing has been mentioned about that. So means the charge which was here, we started extracting or adding, that we have to find. So at this location also, the force due to gravity will be down and the electrical force will be upwards. And the sum of this should be 0. Only thing what is happening is the amount of charge is changing. So we are to find the fractional change in the charge. Means if suppose q was the charge here, small q on that particle, and q plus delta q become the charge at 0, at 0, 0. So as per question, we have to calculate delta q by q, the magnitude of that. If we able to find the E field at this point and this point, we should be able to get the answer. Now the question is how to find the E field at this location and at this location. So we can see the graph. These are the field lines 2, 3, 4, 5 and 6. If we go on the x-axis from the origin, we can see all the 6 field lines are emanating from the 5 division of this graph. And at the same time in the question it is given that these field lines is a portion of field line which has been shown in this graph. These field lines are in rotation symmetrical to the y-axis. So we have taken this circle in the x and z plane with a radius of 5 division. The same circle parallel to xz plane has been taken at point 010 with a radius of 5 division. Let us say that the radius is small r is equal to 5 division. So we know that electric field at any point be proportional to the number of field lines passing through per unit area at that point. So basically, if we will be able to find how many field lines are passing through this circle at 010 and at 00, we will be able to get the order of electric field strength at this location and at this location. Let us say E subscript 10 is the E field at 010 and E subscript 0 as E field at 00. So, but by the definition of symmetry of rotation, we know that the square of the number of coordinates will be the number of field lines that will be passing through this area. So here the field lines in this circle is having only two field lines, 1 and 2, means two coordinate. So from the rotation symmetry about the y-axis, the number of coordinates or number of field lines, because these two coordinates, this and this, we are getting from the field lines, will be square of it. So electric field strength at 010 that we have represented as E10 will be proportional to 2 square divided by the pi r square, the area. The same way, if we see how many coordinates are there for the field lines, 1, 2, 3, 4, 5 and 6, and by the definition of symmetry of rotation about y-axis, we know that the number of coordinates will be 6 square, that is 36, and these coordinates are nothing but the electric field lines emanating. So E field at 00 we can write easily as E naught, or E is at 0, E at 0 is proportional to 6 square by pi r square. So these two expressions we have obtained. Now we will write the equation of motion at 010 and 00. So at 010, mg is acting downwards, q into E electric field at 010, that is E10, will be in this direction, will be 0 because the net, because it is in equilibrium. So q E10 will be mg. So this is number 3 equation. Similarly, we will write at 00 the net force on that charged particle. So now the charge has changed. So we have written Q plus delta Q, right? Mg minus Q plus delta Q, electric field at 0, 0 is equal to 0. This equation 4. So from equation 3 and 4, this will be equal to this. So this is just a mathematics we can solve. So upon solving, we will be getting Q plus delta Q divided by Q divided E10 by E naught will be 4 by 36, 1 by 9. The value of E10 and E0 you can write from the equation 1 and expression 1 and 2. If we are interested in finding delta Q by Q, so we will be subtracting both sides with minus 1. So minus 1 delta Q by Q is coming as minus 8 by 9. So negative sign indicates that the charge is extracted from the particle. In the question it is being asked the modulus, fractional change of modulus of the charge. So delta Q by Q in magnitude, so it will be 8 by 9. If we see the choice, answer D will be our correct answer. Thank you.